crisis here. Sorry, delay.
No problem. I want to welcome all of you to my presentation. So, as we discussed before, this presentation would be about water sustainability. And just as a reminder, this project on renewable energy and water for US and Serbia is funded by US Embassy in Belgrade through basically Department of State through US Embassy in Belgrade is funding this project. And major contributors to the projects are obviously all of you and also Dr. Valeric and Dr. Ellingson and myself. So our goal is to obviously reach the scientists and public as well, both here in Ohio and in Serbia, and to increase awareness about the fields of renewable energy and water sustainability. So as you know, solar energy is currently underused for electricity generation, and we're going to touch on some of those topics today. And obviously, it's important for all of us to keep our water safe, for future generations. So water quality is also very important. So with that, I will basically start my presentation by showing my title slide. So I named this presentation as Water Sustainability for US and Serbia. As you know, my name is Dragan Isilovic, and I'm professor in the Department of Chemistry and Biochemistry at University of Toledo. So University of Toledo is a public university, one of 14 public universities in Ohio. And Toledo is located basically in northwest of Ohio. So if you look at this Google map, you see Toledo is right here. So this is a city of approximately 300,000 people. And Toledo is also located at Lake Erie, okay, so in proximity of Lake Erie. So Lake Erie is one of the Great Lakes, and it's obviously a reservoir that Toledo is using for drinking water. So in proximity to Toledo are also two other big cities. One of them is Cleveland, so to the east, and the other is Detroit. Okay, so if you would go from Toledo to Monroe, Michigan, you would end up in Detroit. So before coming to Toledo in 2008, I actually was a student at University of Belgrade, where I earned my Bachelor of Science or diploma in physical chemistry. So this was in 1998. I then worked for a couple of years at University of Belgrade in the same department. Then I started my graduate school at Iowa State University in Ames, Iowa. So I spent almost 6 years there, and then moved to Indiana University in Bloomington, Indiana in 2006. And then, as I said, started in Toledo approximately 14 years ago. So I will just give you a brief introduction about Toledo. I want to point out that many people think about Toledo, Spain, when somebody mentions Toledo, but Toledo is another city which obviously is located in Ohio. And here I'm showing basically a photo of downtown Toledo. So we just got our first snow during weekend, and over the night, we have, I don't know, 1 centimeter of snow, so less than an inch of snow on the ground. This picture was taken a few years back, and actually what it's showing is a big river that goes through Toledo, and it's called Maumee River. So Maumee River is the major tributary of Lake Erie, and actually originates in Fort Wayne, Indiana. So it flows through mostly agricultural fields before coming to Toledo and then entering Lake Erie. And it's important for this lecture because, as we're going to see, water quality in Lake Erie depends basically on the nutrients that Maumee River brings in Lake Erie, and this will be discussed later on. So Maumee River is approximately similar size as rivers in Belgrade. So I would say maybe as same as Sava River, maybe slightly smaller than Dunav in terms of the width. And now if you look over on the other shore, you see downtown Toledo. So Toledo is, it used to be an industrial city, mostly manufacturing glass. Okay, so nickname for Toledo is Glass City. And if you look at the right, this is, you see a few buildings here. So this is downtown area where there is a basically science museum for kids, and there are many other activities, including this stadium, which is for a semi-professional baseball team called Mud Hens. So obviously, when you have, a couple 100,000 people, living on the shore of a river, or close to the shore of the river, there is much of influence of, both individuals that live around the river, but also the industry that is located in Toledo. Now, University of Toledo, as I mentioned, is a public university, and it's located in approximately, a few miles away from downtown Toledo. So it's basically a suburban campus that you can see on this picture here. I want to point out that this year marks 150 years since the University of Toledo was established. Here you see this big tower, which is basically part of the building called University Hall. So throughout those 150 years, in university has been growing, adding new departments, also adding a medical campus, which is approximately 10 minutes away by car from this campus. So what is different between universities in Serbia and universities in Ohio? So most departments are actually located on one campus. And if I point out to the right, you can see the building that it's labeled as Wolf Hall and Bowman Audi Laboratories. And this is where my laboratory is located. This is where my office is located. You can also see other facilities and buildings on campus. I want to point out there is a football stadium. American football is quite popular in the US, obviously. And there are other recreational facilities here. As a side note, there were students from Serbia and other Balkan states who were studying at University of Toledo or who are currently studying at University of Toledo. So some of them play tennis, other swimmers, those that I know. Now, I want to point out that Professor Allingson's lab is basically on the other side of the campus, but also physics department is basically this building in proximity to basically my building and University Hall. So currently, university has somewhere around 16,000 students. At its peak, let's say 10 years ago, there were more than 20,000 students. So most of those students are undergraduate students, and some of them are graduate students. So university itself is ranked around 970th place among best global universities. Department of Chemistry is ranked as 661, so it's basically among the top chemistry universities in the world. Obviously, it's important to point out that those rankings may be relevant in certain disciplines. What I want to point out is that the facilities that we have at University of Toledo and scientists that I work with are, let's say, very smart people, and they do most of the time, they do high-tech science. So with that, I want to basically introduce what we're gonna learn today. And major term that I want to use throughout this presentation is water sustainability. So all of you have heard about this term most likely, and I looked at online to find a suitable definition. So at this site reference, they mentioned that sustainability basically corresponds to use of water without compromising its availability for future generations. Now, we all know that we want to keep water safe for the future, for the future use. And there are obviously many environmental, economical, and ethical standards that should be accomplished, in order to maintain water safe for drinking and for other type of applications and use. So it's no-brainer that we should avoid polluting water. Throughout this presentation, I will mention a couple examples that relate basically to pollution of water with oil, which has happened in Ohio in 1950s and 1960s, and also mention pollution of water with cyanotoxins, which are basically molecules that are unfortunately found in, so toxic molecules that are found in Lake Erie. And one recent example involves basically lead being located in water, in drinking water, so tap water in Flint, Michigan. And this was obviously a big news a few years back, and it was basically due to changing the water source for Flint, Michigan, which resulted basically in water being intoxicated with lead. And this resulted basically to intoxication of many citizens of Flint, Michigan, including children. You all know and hear this, there is a big problem with plastics, not only in the US, but also in Serbia and other parts of the world. Environmental activists are going around and are collecting plastics, that people dispose. So this is obviously important to avoid in the future. We also want to minimize interference with water cycle in nature. We all are aware, that water will evaporate and then condense, as rain or snow, it will fall on Earth, and with our everyday activities and obviously with industrial process, those water cycle process in nature is affected, and this leads to different processes that we want to avoid. And one of them obviously is melting of ice on North and South Pole. The other would be obviously events. So those events of interference with nature water cycle lead to increased chances of severe weather, and along with climate change, many of our activities basically influence this water cycle. So bottom line is that we want to avoid hazardous situations, which sometimes lead to death of people. So if you look at some other, so I'm trying to advance here just a second. Okay, so look at some other topics that we're going to cover today. So we're going to talk a little bit about the impact of energy on the quality of water. As I mentioned, we have this issue in Lake Erie water that cyanobacterial toxins end up in Lake Erie water. Luckily, we have a water treatment plant that in the peak of those so-called cyanobacterial blooms can remove most of cyanotoxins. Cyanotoxins are found also in other parts of the world, including Serbia, and I mentioned one example about that as well. So obviously the goal of this presentation is also to make you aware that there are efforts going on to improve sustainability, and we'll discuss about them as well. I'll show you some examples of basically using thermoelectric power plants that burn coal and its effect on Lake Erie water, and in particular its microbiome. And as I mentioned earlier, I'm going to show some examples of water environment pollution in Ohio, US, and Serbia. So what are water sustainability drivers? We obviously, every day, population of the world is increased. So you probably have heard recently that the number of people on Earth is estimated to be 8 billion. Which is obviously a huge number, and everybody needs to have access to safe drinking water, which nowadays is not the case. Talk about US population, the data that I found, show that US currently has 332 million people, Serbia has approximately 7 million people, and all of us would like to have access to water and energy. We experience, some climate change effects that are unfortunately due to human activities. So Dr. Alex was talking about that during his presentations, and I think it's important to acknowledge that climate change is ongoing, and certainly we should try to solve it. Now, as you're going to see on the following slides, the biggest uses of water are for energy and food production. So if we consider some of the quantities that I'm going to discuss on the following slides, we're going to talk briefly about water usage in the US and also in Serbia. And water usage is simply quantity of water used. Now, if you talk about water use, part of the water is basically removed from the sources, and this we call water withdrawal. So I abbreviate here as WW, just kind of to have some type of equation here. And some of the water that is used is discharged after the use. So I abbreviate that as WD. So this is the quantity of water that is returned upon the use. And it's here I labeled water consumed. Okay, so obviously, if a plant withdraws some water, from a reservoir, it may use some of the water and turn back, but some of that may be consumed, so it could be evaporated, as we're going to show in some of examples, or it could be incorporated into products. So since I'm a chemist, obviously there are chemical reactions that will lead to products that will consume water. Now, water consumed basically is simply the difference between water withdrawn from the sources and water discharged after the use. Okay, so this is obviously an equation that relates those three quantities. So if we look at some data from US, I know I mentioned previously that most of the water is used for electricity production and for basically in agriculture to produce food. And if you look at this data for water withdrawal, for water withdrawal in 2009, so around 49% of the water withdrawn was used to generate thermoelectric power. So what is thermoelectric power? So obviously you have many plants that burn fossil fuels, such as coal, oil, or gas, or less often waste products. Also, nuclear power plants and geothermal energy would correspond also to thermoelectric power plants, because in all of those plants, you have heat basically generated along with electricity. So what is, as mentioned here, either used to generate electricity with steam-driven turbines, or it's used to cool down generators and other equipment. And I would say most of the time, both of those. So now you may certainly think that if water is used to cool down, it will there will be transfer of heat from equipment that is used in electricity generation to water. So this hot water then needs to be cooled down and evaporated. So if you look at the picture to the right, which shows a thermoelectric power plant in Georgia, in US, one of the US states, you see those towers, and you see that much of the water basically it's evaporated, as we mentioned, consumed in this case. So that hot water should not be released in a lake or river that is next to this thermoelectric power plant, but rather it should be cooled down, and this is done by basically spraying water in those towers, and then you see the steam coming out, so water is evaporated. So if you look at more recent data, and this is the year of 2015, not much has changed. Okay, so again, most of the water is used for either irrigation in agricultural fields, or to produce thermoelectric power. Okay, so slightly less than in 2009, but around 41% of water withdrawn is used to basically, as I mentioned previously, to produce electricity in the turbines, or to cool down generators of electricity. Now, on the top of this slide, you see that I mentioned that the distribution is similar as in 2009, and now we have some numbers here for total water use in water. So this is a huge number, so 322 billion gallons per day. So those of you that are in Serbia, you may not be familiar with the unit called gallon. So in the States, we use liters, obviously, and some other units such as milliliters in chemistry labs and in some areas of research. but in everyday's life, we often use this term called gallon. So gallon is approximately 3.78 liters. Okay, so almost 4 liters of liquid. So, for example, gasoline or milk is sold in gallons. So per day, you have a huge number of, basically huge volume of water that is used in the USA. And if you look to the graph to the right, basically you could see that most of that water it's removed basically from surface reservoirs, so around 61.6%, and some of that is groundwater. So approximately 87% of all water used per day in US is basically fresh water, and about 12% is saline water. Okay, so water from ocean or from underground saline water. So how does that relate to what is available to the US, in particular to the region where we come from? So basically region of Midwest and Ohio. So Ohio and Toledo, it's very close to all Great Lakes. As I mentioned, Lake Erie is just basically next door, like, I know, half-hour drive from University of Toledo. You see other 4 Great Lakes are Lake Ontario to the right, and you see Lake Michigan to the left, and Lake Huron, which is also basically between Canada and state of Michigan. And on the top you see Lake Superior. So those 5 Great Lakes account for approximately 21% of world fresh water. So we are lucky, we are fortunate to live basically in an area that has abundance of fresh water. As I mentioned, those lakes are often supplying water to, like Lake Erie supplying water to Toledo. And what's also highlighted here are basically some areas, so basins that will bring water into particular lakes. I just want to point out that I mentioned the Maumee River, which goes from Indiana. Okay, so approximately, this yellow part of the map of Indiana, from Indiana to Ohio, and it goes to those agricultural fields. So this is the major tributary to Lake Erie, and we should account that whatever ends up in Maumee River, if it's soluble or if it flows, will end up in Lake Erie eventually. So this is very important to keep sources of fresh water safe. So if you look at Serbia is also fortunate to have many sources of fresh water. So here I mentioned that water in Serbian language is pronounced as voda, and what I mentioned here is voda Serbia would mean basically water in Serbia, or Serbian water. And major rivers in water are Danube, which is obviously one of the biggest rivers in Europe, which flows through several countries, entering Serbia, and then basically ending up in the Black Sea after that. And the other big river is Sava, which again nowadays flows from several countries, including Croatia and Slovenia. Other big rivers are Drina, which is on the left, based on the border with Bosnia and Herzegovina, and River Morava, which basically flows from the south to north. Serbia has a few big artificial lakes. I mentioned only a few that are kind of important. So Đerdap, for example, is a lake that's important for generation of electricity. I mentioned Zvorničko jezero, which is Zvornik Lake, which is also based on the Drina River, which is also, I believe, used for electricity production. And for example, this lake Čelije is used to supply water for city of Kruševac, which is somewhere around the middle of the country. In the north of the country, there is basically a lake that was made by basically wind removing the soil, and this lake is called Palić. There are also some mountain lakes which are very beautiful, And certainly this is something to consider if you ever visit Serbia. Now, if you look at water withdrawal, this is now expressed in meter cubes rather than gallons, and water withdrawal in Serbia is 5 billion meter cubed, and I'll show the data on the following slide. Industrial withdrawal is accounting basically for 3.7 billion meter cubes. Okay, so if you look at the percentage, approximately 2/3 of water withdrawn would be used for industrial applications. And then if you consider wastewater, the data that they found in this publication from the Serbian government says that there was around 100 million meter cube of wastewater generated in 2021, and 29 million of this was purified. So obviously, all of those data come from research that I'm showing here, and it might be hard to see those numbers, but basically I mentioned around 5 billion meter cubed. You know, here it's shown in millions of meter cubes, so it's showing as 5,000 approximately. So this is the amount of water that has been basically used, and also this graph shows on the right, basically you have translation in English. Okay, so you have water that is basically abstracted and used, and water that is basically after use discharged as wastewater. So there are some branches of industry that use more water than others. Okay, so obviously these days in Serbia there is much discussion about mining of lithium. So mining is using certain amount of water. Obviously, the bigger problem is that you know, some of the discharge may contaminate either water or soil. So a part of that water is used for public supplies. So most of citizens of Serbia actually use public water supplies, and this is similar for Toledo. You know, there are some people who have wells, you know, in their backyards, and they use this well water for use, but I would say in Serbia most people use public water for drinking, and water in many parts of Serbia is very good. Obviously, there are parts of Serbia that don't have high quality water or have contamination, so this is something to consider. So now you heard that word, that picture is worth 1,000 words. So here I show a photo of Lake Erie, which I mentioned to you is the source of water for Toledo. If you look at this shore of Lake Erie, which is in a park, basically state park called Mami Bay State Park, so this is approximately half an hour from the University of Toledo by car. So lake at this time of the year was very clean, and this is obviously something that we would like to see on every day basis. Now, one reason why Lake Erie would get polluted is that there are obviously much industry and people living around. As I mentioned here, there are multiple power plants that are located on Lake Erie. This results in change of water temperature, because we said, you know, there is some water that is discharged, usually cooled down, but you know, still there is a change in temperature. So this water could be discharged also in tributaries, you know, from other processes, not only electricity generation. And obviously, when you supply water for 500,000 people, you need to be extra careful, you know, that you basically don't contaminate water that will, after the treatment, be used for drinking or other activities at homes of approximately 500,000 people. There are many production facilities in Toledo. I mentioned glass industry, but nowadays what is more relevant to us is basically that First Solar is located in Toledo. There are other companies, you know, for auto industry and for other manufacturing facilities that are, some of them are close to the lake, such as refineries, but not exactly on the lake. As I mentioned, Toledo has an excellent water treatment plant. So the water that I drink, for example, comes from the faucet. I do use a filter, you know, that will remove major contaminants, including some of the metals that may accidentally end up in water. And lake is used by many people for recreational activities and also economy. So in particular, I want to mention that during summer, there are many boats on the lake and people fishing. So this is something to basically consider when you talk about Lake Erie. So it's not only source of water, but also very important for economy of Ohio and also Michigan and other states that are around it, including Canada, obviously. So if you look closer at this picture that I showed on the previous slide, you can notice basically there are two power plants that are located on the Michigan shore. So city of Monroe is approximately halfway between Toledo and Detroit. So if you drive from Toledo to, for example, Detroit Airport, you pass through Monroe, Michigan, and almost every time I pass there, I smell some, bad smell of what I would think are some sulfur-containing compounds. And it's very likely that they come from this coal-based power plant, which is shown on the left. Okay, so I zoomed in the previous picture, and I'm showing basically to the left, I'm showing a steam that comes out from the carbon-based, so basically power plant that's using fossil fuels. And this particular power plant is obviously supplying electricity to many households in Michigan and very likely in Ohio too. And it's supposed to close in 2028. Okay, so hopefully they're going to transition to cleaner energies in next 5 years. Now to the right, you see what I label here as a carbon-free power plant. So this is actually a nuclear power plant called Enrico Fermi. So Enrico Fermi was obviously Italian physicist who worked in the States, and this nuclear power plant is located on Lake Erie, also in Monroe, Michigan. Luckily, it's a carbon-free power plant, but still it's on the lake, okay, because as we said previously, water is used to cool down the equipment. So it is very important to remember that some of this water would be discharged, okay, and lead to heating of water and pollution. Some of that steam that is released would locally increase the temperature, and as we mentioned previously, as Dr. Alex was mentioning, there is increasing carbon dioxide that comes from those coal-based or oil or gas-based power plants that will lead to basically increased chances of global warming. And one other thing that I kind of tried to indicate previously, is that the major tributary to Lake Erie is Maumee River. And I mentioned here that it will bring fertilizers that, basically run out from the fields. So many, many farmers use fertilizers to grow corn or soybean that on the fields next to the Maumee River. And then we have those events, such as thunderstorms and much of rain. Those fertilizers will run out from the field into Maumee River, and they will basically act as nutrients for harmful microbes such as cyanobacteria or algae. And this leads to a phenomenon called cyanobacterial harmful algal bloom, which on the following slides, basically I just abbreviate as HAB. Okay, so those HABs are basically overgrowth of cyanobacteria. In old days, those cyanobacteria were called green-blue algae, and this leads to obviously after those cyanobacterial cells die and lyse, basically this leads to release of toxins, which are called cyanotoxins, into Lake Erie water. I want to point out that this phenomenon of CHABs is relatively newer compared to something that has happened in Cleveland, Ohio, on Cuyahoga River in 1950s and 1960s. So due to oil on the river and debris that was floating that contained oil, there were a few times when Cuyahoga River caught on fire. And this is also a big river that was surrounded by manufacturing places. And at that time, there was no awareness of people or companies that this may lead to catastrophic events, such as those fires that were actually in the end was demolishing boats and hurting people and adding to additional pollution, that obviously comes from all this smoke. If you talk about Lake Erie, and especially in recent years, so in 2000s, we have many years when we see lake water basically during months of July, August, and September being green, especially the shore. So as I told you, this results from the phenomenon called harmful algal blooms, and major driver of harmful algal blooms are basically nutrients that come from through Maumee River to the lake. So in particular, cyanobacteria need phosphorus and nitrogen to grow. Nitrogen is also part of those toxins that are produced, and mostly they come from runoffs from sewage and agricultural fields. So I will mention two particular species of cyanobacteria that are relevant to this presentation. So one of them is Microcystis, and the other is Planktothrix. So Microcystis aeruginosa is basically the species that leads to this green color of the Lake Erie. So it's predominant cyanobacteria in Lake Erie. But Planktothrix has also been discovered in Sandusky Bay, which is in proximity to city of Sandusky, so approximately an hour away from Toledo, basically between Toledo and Cleveland. So unfortunately, those cyanobacteria produce toxins called microcystins and some other toxins that we won't discuss in today's presentation. So microcystins are liver toxins. They can cause cancer, hemorrhage, or failure of liver. And there were cases when people died of microcystins, which I will mention later on. So inhalation and ingestion commonly lead to basically exposure. So these are the ways of exposure to microcystins. Unfortunately, microcystins have been found in drinking water, both in Serbia and in Toledo. So we will mention briefly this case of a reservoir in Užice, which was containing microcystins coming from Planktothrix cyanobacteria. And Toledo in 2014, we had a weekend when basically our water supply, although it was open, they recommended not to drink water because the amount of microcystins in water was higher than what's recommended by environmental protection agency. So there is much more research and education that should be done, both to educate citizens of US and Serbia about, influence that be sometimes due to man-made, human-made activities, are made to those lakes. And this is something that our project would be focusing on. So if I look at the following slide, if I show you the following slide, you may notice that those harmful algal blooms are detected not only from the shore, but they could be basically imaged from satellites. So this particular image to the left shows harmful algal blooms in western basin of Lake Erie. So Toledo is approximately here, and you see that in this year, so we are talking about year of 2017, the bloom was spreading to Putin Bay. So these are a few islands here. Putin Bay is an island in Lake Erie, and also toward Detroit. Okay, so most of the bloom is actually in the delta of Maumee River, but some of that is in close proximity of water intake for Toledo water plant. So this is a way to monitor appearance of harmful algal blooms. So you have agencies such as NASA and United States Geological Service that use basically to look at fluorescence of chlorophyll from the satellites, and they can basically estimate the bloom size and severity by imaging from the planes, for example, or satellites. The image on the right shows basically microscopic image of Microcystis. So this bacteria is more than 10 microns, so we cannot see it by our eyes, but the reason why we see water being green is that we have actually many colonies of bacteria. So those bacteria live in colonies, and when they overgrow, water is green. This image was done by black and white camera on a Nikon microscope by a former student of mine, and you see that those cells are approximately 5 micron in diameter. And you see many of them because obviously they overgrow in water. If you talk about microcystins, I mentioned these are, hepatotoxins, so they affect liver. I'm showing here the structure of microcystins, and these are molecules that some of my students work with. My laboratory is working mostly on analytical chemistry of microcystins, so we are involved into identification and quantification of microcystins, as well as some other biomolecules in water and biological fluids. And I want to point out that each microcystin has this unusual amino acid called ADA, and it's actually each microcystin is a cyclic heptapeptide. So that means there are 7 amino acids in this ring, and one unique amino acid that is found in microcystin, mostly in this form, is called ADA. So this ADA amino acid is useful to basically identify different congeners of microcystins. But even more importantly, there are 2 amino acids that vary between different forms of microcystins. So those amino acids that are labeled with X and Y would have different chemical structure. The technique that we use to identify microcystins is called liquid chromatography mass spectrometry, or LCMS. And if you look to the right, you see this inset where with some of the standards that we analyze, so some of the microcystin standards. So MCLR means that at position X, you have leucine, at position Y, you have arginine. MCRR means that at both positions X and Y, you have arginines, and so on and so forth. So as mentioned on this slide, there are more than 300 congeners that were identified by many of them by liquid chromatography mass spectrometry, some of them by some other techniques. And what is important is that those are liver toxins, and they can basically lead to death. Okay, so they bind to, they inhibit those enzymes in liver called phosphatases, and this could lead to liver failure or in severe cases to death. One well-documented case of death due to microcystin happened in Brazil in 1996. So more than 52 people died in a hospital because they were dialysed with water containing microcystins. So this is why environmental protection agencies such as US EPA basically they advise water treatment plants that in the case they detect microcystins at concentration of 0.3 micron per liter or higher, they should basically advise people not to drink water. Now, luckily in Toledo we have a very good water treatment plant, and they are monitoring microcystins among many other molecules and ions that they monitor. And I mentioned do not drink advisory case in 2014. So during a weekend in August of 2014, Toledo residents were advised not to drink water, because if you look at to the graph to the right, you see that around August 2nd, so for a few days, the amount of microcystin in water was larger than what was required at that time to be less than 1 ppb. So that that requirement is now even more stringent. I told you nowadays water should contain less than 0.3 micron per liter in order to be safe for drinking. At that time, the amount of microcystins in water was actually 2.5 part per billion. So although this sounds very small, okay, so 2.5 part per billion means that you have basically 2.5 micrograms in a liter of water, so very small amount. But unfortunately, at that time, we were not allowed to drink water, and this have led to basically further push from the government to improve both water treatment process and to do research, that will help basically avoiding those risks of microcystins in water. I mentioned that Toledo, like many other cities in the States and obviously some cities in Serbia, have a way to remove different molecules, including cyanotoxins from water. So generally, when water that comes to Toledo water plant is treated in multiple steps, including coagulation and flocculation. At that step, after water intake, powdered activated carbon is added. After the steps of filtration and disinfection. Basically, what happens, granular activated carbon is used to further remove, not only microcystins, but also other contaminants from water. So water in Toledo is high quality, I would say, and every year we can read, water quality report. Luckily, they have added some new capabilities for treatment of water during summer months when those harmful algal blooms are pronounced. So I mentioned previously that nutrients lead to overgrowth of algae. Lake Erie, close to Toledo, is also very shallow. So during summer, we have much of heat. Cyanobacteria are photosynthetic organisms, so they would multiply very much and produce those cyanotoxins. Besides activated carbon, there are a couple other processes that are used in Toledo water plant. One of them is chlorination, which is obviously used in Serbia as well. And the newest addition to the plant is ozonation, which would also efficiently remove microcystins. So despite water in Toledo being relatively expensive, if you look at water bills, luckily it's very clean and safe for drinking based on the analysis done by chemists in Toledo water plant. So what I want to point out next is that there are some unusual events that happen due to influence of basically power plants that are nearby Toledo. Actually, in particular, those that are power plant, so coal-based power plant in Monroe, Michigan. So a few years back, a new species of cyanobacteria, so new to Lake Erie, was discovered in near Michigan shore. And this species is called Lyngbya vole and may produce actually neurotoxins, which are called paralytic shellfish toxins. So obviously there's more research that should be done in this field. We generally don't see this Lyngbya vole in Western Lake Erie, but potentially due to heating of the water from the power plant, those cyanobacteria were able to survive winter and they may continue to grow. So this is basically research that was done by Professor Tom Bridgman, and I'm showing his picture on the next slide, basically in order to point out to you that we as scientists could play an important role and in not only research but also education of future generation of scientists, and also help administrators and politicians deciding what potentially could be new steps to basically do something from the government side. So Toledo has Lake Erie Center, which is found very close to the intake of water for Toledo water plant. So if you look at this picture, this is Professor Bridgman and his student, and they're monitoring basic quality of water around water intake for Toledo water plant. And I also want to acknowledge his role in establishing what is called University of Toledo Water Task Force. So I'm one of the members of University of Toledo Water Task Force, and there are more than a couple of dozens of professors working on water-related research. And obviously, I want to brag a little bit about Performance Water Task Force. So we were awarded some public award recently. And obviously, the story is not here about the awards, but rather that scientists, including professors and students, can contribute much to basically both new discoveries in fields of science, but also to spreading the word about drivers of different environmental effects, about quality of water, and in general about water sustainability. So as I kind of indicated earlier, those harmful algal blooms are not common only for Ohio. It happened all around the world. So if you look at this graph here, you see some types of cyanotoxins. So for example, besides microcystins, you could find other groups of toxins such as nodulurins, such as saxitoxins, anotoxins, cylindrospermopsin, and so on and so forth. And you could find them in different parts of the world. Okay, so if you look at all continents, including Antarctica, there were some cyanobacteria found. And since we are basically representing here water sustainability projects in US and Serbia, I want to point out next about case that happened in Serbia. Okay, so if you ever see, something that you may suspect, if you ever see water that could be contaminated with harmful algal blooms, certainly want to avoid water because like microcystins can affect liver, neurotoxins such as saxitoxins and other toxins, and BMAA can affect brain, and so on and so forth. So there are obviously many dangers even to swim or fish in water that is contaminated with toxins. And this leads to the next slide that I want to show you about the case of contamination of Lake Brutsi with Planktotrix cyanobacteria. So Planktotrix also produces microcystins. So we said in Lake Erie, major cyanobacteria is Microcystis aeruginosa, and we find Planktotrix in Sandusky Bay, which is one part of Lake Erie. In Lake Brutsi, which is reservoir of drinking water, which used to be a reservoir of drinking water for city of Užice in Serbia. What happened is in 2013 they have noticed, those mats of red color that corresponded basically to Planktotrix cyanobacteria. And at the same time, they have noticed that fish in the river start to dying, and people were complaining about water taste and also having some health-related issues. So thanks to scientists from Serbia, Greece, and Finland, basically they have documented, first they have found that those Planktotrix cyanobacteria have released cyanotoxins in water, in particular microcystins, and they have documented this story in a book that was published a few years back, whose cover is shown on the left side. So obviously, if you talk about those cases, this is probably not the only one in Serbia, but after it was discovered that Lake Brutsi contained microcystins, city of Užice changed its water source and obviously kept citizens of Užice more safe. Okay. The last case that I want to talk about HAPS before we switch back to some other effects of electricity generation to water quality. I want to mention this relatively novel case of toxins that were basically killing bald eagles. So in around 10 states in southeast US, there were bald eagles, dying for years. Okay. And as has been noticed and shown in this last bullet point, those eagles were basically eating some waterfowl. Okay, so some ducks, I would call them ducks, because they look like ducks or geese. And those animals were actually exposed to cyanobacteria on the plants, that were living in and around the lake. And through basically extensive research of scientists and engineers, basically it was discovered that this is a new toxin that actually contains multiple atoms of bromine. So here you have a formula. So they call it basically using a Greek word, they call it as a poison that kills the eagle. So the take-home message behind this slide is that although we know what major toxins are released by cyanobacteria, and although we know what are the major pollutants in water, still there is possibility that new species of toxic molecules will be generated through either bioevolution of organisms or through man-made activities. Okay, so obviously source of bromine, as mentioned here, still I think I never mentioned here, but still exact source of bromine is not known. But if you have a molecule that is so brominated, it's no wonder that it will have physiological effect on both animals and people, and in this case led to basically death of eagles. So now going back to production of electricity. So if you look at production of energy in Serbia, coal is still the major basically source of basically major material used for production of electricity. So this is data that show contribution of coal based power plants to production of electricity. So the unit that is mentioned here, TJ, stands for terajoules. Okay, so 10 to the 12 joules. So this unit of energy. And if you look at the amount of energy produced by different forms of materials used for energy production. Coal still accounts for, based on this table, accounts for 65% of all energy produced in Serbia in 2020. As we discussed in previous presentations, this is, not good for the environment and not good for global warming as well. So it would be good to kind of get rid of power plants that use fossil fuels, okay, in order to avoid contamination of the environment and global warming. Hydroelectric energy, based on this plot, accounts for around 7%. Now, thanks to Dr. Mastilovic, who emailed me after I sent this slide. He found another source, that indicates that contribution of hydroelectric energy actually should be more than 7%. And this is what I remember, from previous presentations and what I learned a long time ago. So hydroelectric energy is another big source of energy in Serbia. And unfortunately, if you look at energy of wind, and we'll mention this on the following slide, and energy coming from natural gas and solar energy, it's very small contribution of those energy sources so far. So I want to show you those additional data on the following slide. And on the top, I use this source that I obtained from Mishko, Dr. Mastilovic, who sent me this Power Supplies of Serbia technical report. So if you look at those data, which are now shown in gigawatts per hour, okay, so watt obviously is unit of energy, and generally for generation of electricity, we express this energy per hour. So again, those thermal power plants will account for most of the energy produced. Hydropower plants will account for, based on this data, around 27%. And I cited also Dr. Valjic below, actually her source, that says that if you consider only renewable sources, hydropower accounts for around 88%, wind accounts for around 9.6%, biogas for 1.7%, and solar cell accounts for a very small percentage. So this indicates big opportunity for renewable energy and its development, okay? And also it will help with water sustainability. As we discussed before, if you don't use, coal-based plants that would use, water to cool down equipment, and also water as steam to basically run turbines, then obviously we're going to avoid some of the problems that we have, with heating of water sources and with basically pollution of water sources as well. Government of Serbia is optimistic about basically securing, so basically reaching 50% contribution from all renewable sources by 2040. I cited an article from that I found online. So what I hope for is all of us will be alive by 2040, and hopefully all of us will witness that Serbia has improved, contribution from renewable energy sources to total energy production. This other table is showing basically very similar data that I showed, that Dr. Valjic presented previously. So basic contribution from different renewable energy sources, including hydroelectric energy, very small contribution currently from solar energy. I would say decent contribution from energy of wind, and they mentioned here as wood fuels, significant contribution. I think this could be point of discussion, but I would like, coming obviously originating from Serbia, I would like that people use some more cleaner sources for energy generation, so to basically decrease the amount of wood that is used to heat both homes, but also used in energy production. So last set of slides basically shows some connection between renewable energy and water. Okay, so this is what scientists call renewable energy water nexus. So we already discussed about use of water for cooling in thermoelectric plants. Solar energy, on the other side, does not use water during operation. Okay, so this is different than for thermal power plants that we mentioned previously. There is big potential for geothermal water and wind. Okay, so currently they're underused. I would say in Serbia in particular, geothermal energy is underused. Now, on the other side, even those companies that make solar cells, they realize that they need to consider water use in production of solar cells and turbines. So this is very important that water is used not only during production of solar panels, but also during production of other equipment. So there is more to this to come. I just want to actually show you a couple of encouraging slides. So one of them shows annual rate of energy and water consumption and gas emission US. Okay, so what I see as encouraging here is that people in industry consider, that they need to minimize emission from the gases, during water consumption and energy production. So if you look to the right, those arrows that are pointed down. So if you go from year of 2014 down and look at the values for 2019, you see that the amount of carbon dioxide released, and this is now expressed as basically in units, basically of megatons per megawatt hour produced of energy. So you see that those gases, amount of the released gases such as carbon dioxide, sulfur dioxide, and different forms of nitrogen oxides are decreasing from 2014 to 2019. And hopefully that trend remained, during COVID years and is the same, it will go down in the future. Now, water consumption, which is labeled with water CF, okay, and expressed in meter cube per megawatt hour, has basically slightly increased. Okay, so in 2014 it was 2.15, in 2019 is 2.17. Also, water withdrawn, for basically per produced megawatt hour from 2014 to 2019 has slightly increased as well. Now, if you look at those units of thermal units of energy, which Dr. Anderson mentioned before, per produced megawatt hours, they have slightly decreased. Okay, so there are some encouraging trends, and there are some trends that should be improved more. But in this paper, that I cited, and I want to point out that I was recommended to cite this paper by scientists working in First Solar, Dr. Parikh, Dr. Sinha, sorry. So I did discuss with him, about what his company is doing, and he also mentioned, "Oh, look at this paper. It's showing, some encouraging trends." And this what he told me to read, and then I kind of interpret as showing encouraging trends. So Dr. Sinha, who I also cited in the previous slides, he mentioned that his company, so this is now First Solar, which has facility in Toledo, Ohio, actually in Parisburg, Ohio, which is suburb of Toledo, and also has companies in Arizona and other places. They're paying much attention to water sustainability. So if you look at their water consumption, now we're talking about water consumption for manufacturing, it decreased 78%, and this is due to improvements in efficiency, improvements in manufacturing, and also due to water conservation and recycling. So from 2018 to 2021, okay, so they have around 87% reduction. 78% reduction, and their target for 2028, they expect to have additional 87% reduction. So with this, I would like to conclude my talk. I put a few bullet points here. So one of them is basically, sorry, I forgot that I'm now somehow switched to my PowerPoints. Okay, so I didn't show this previous slide. Okay, so this is the slide that I was talking about from First Solar. Okay, so we have 78% reduction from 2008 to 2021 in their manufacturing facilities in terms of water consumption, and in 2028 they expect to have additionally 87% reduction. So I mentioned that I have a few bullet points to conclude. So again, it's very important for us to prevent pollution of water and reservoirs that provide drinking water. So this is obviously vital for our future. renewable energy could play an important role, okay, in water sustainability. Obviously, I mentioned sources from different studies, including companies, you know, that basically work on in this field. And it could decrease, renewable energy can decrease influence of climate change and reduce use of water, okay, especially for in thermoelectric plants. The regulations and subsidies by the governments. I know government of Serbia is also doing some work in this area. I want to mention recent US government policy, you know, called Inflation Reduction Act, which would basically provide subsidies for, you know, improving renewable energy sources, which will obviously help climate change and water sustainability. All of us obviously can contribute to and improve water sustainability. There is social and environmental dimensions to this. I mentioned discussion about lithium mining in Serbia. Many people are reluctant to approve mining of lithium in Serbia due to pollution of water by lithium and also by chemicals that are used in lithium mining and extraction. So with that, I would like to acknowledge US Embassy in Belgrade for funding, collaborators, including you know, collaborators at the University of Belgrade and Vinci Institute, all of you as participants, many scientists and agencies that basically contribute to field of water sustainability. Some of them I cited, and probably all of you have read some of the literature or news about basically water sustainability. Finally, I want to point out that University of Toledo is celebrating 150 years. So it was established in 1872. So this year marks 150 years. And we are fortunate to basically collaborate with scientists in Serbia at University of Belgrade, and fortunate to be funded by US Embassy in Belgrade to do this project. I'm looking forward to your questions. So this is the end of my formal presentation. You're welcome to turn on your camera, sorry, and ask questions or lead to discussion from this point on. Thank you all for your attention.
Thank you very much, Dragan. I just want to add something before we go into discussion and questions. I just want to say thank you very much. And I think we're really fortunate here at the University of Toledo and as part of this project to have such excellent faculty, including Professor Isalovich working on water sustainability issues, which within the United States, Toledo is a real leader in this area, and the University of Toledo in particular. Dragan can tell us more about that. He already has, but there's one other thing I want to mention and real briefly here, and that is some news that I'm sharing on my screen right now, that yesterday, First Solar, which is almost synonymous with large-scale photovoltaic panel manufacturing, just announced a new factory to be built for the first time outside of the state of Ohio in the state of Alabama. So I can put this link in the chat and you can take a look at that later. Okay, thank you.
Thank you, Randy. I think, as I mentioned before, you know, I appreciate your time, you know, that you invest in this project, since you manage many other projects, and same for Ivan, you know. So yeah, I'm lucky to have you as contributors and collaborators here.
Thank you, Dragan.
Yep. So any questions? As I mentioned, Mishko has provided some reference, and certainly all of you have some knowledge about the current situation in Serbia in terms of water sustainability. I have heard about some issues, you know, for example, in the city of Zrenjanin, which is in north of Serbia. But I also should acknowledge that where I come from, so this is a small town at Compounding Mountain. It's called Bruce. Quality of water, actually, the taste of water is very good. So obviously I'm probably biased because I grew up there, but I like when I go there to drink water, you know, from the tap, you know.
Yeah, that's mountain.
I have several questions, some of which you've already addressed in your talk mostly. But I guess one question is there public information on any kind of, real-time update, or maybe not real-time minute to minute, but day by day, that measures the microcystin concentration at locations in Lake Erie? Is there something published online about this?
Yes, that's a very good question. So in that picture that I showed, where Dr. Bridgman is holding, some type of sensor, it's a buoy so there are buoys, around Toledo water plant intake. So there are real-time data, on microcystin content, or I would say real-time in terms of number of cells, because I believe that sensor is using, looking at chlorophyll. So it can measure, the cell density, and this could warn, not only citizens, but in particular, managers of Toledo water plants, so they can change the treatment. As I mentioned, there are different processes, so they remove the cells, through coagulation. They can, they go through process of filtration, adding activated carbon. But recently they also have ozonolysis plant, which was built to, in particular, to remove some contaminants that could be removed by ozone, such as microcystin. So yeah, there are real-time data, and I will find, I'll provide this information to all participants, next time.
I have just a couple more questions, and that we can get through, and then other people can ask questions. But I have a question about, you described how the water is treated to make it potable and safe, and I'm just wondering if you are able to talk about the environmental impacts of that water treatment process, or is it pretty minimal impact?
Yeah, well, this is, there is ongoing research. So once you use, for example, activated carbon, and if it absorbs natural organic matters, and, if it absorbs microcystins, you need to dispose this, generally, ideally you would like to regenerate. But all of this sludge that comes from water treatment process, eventually would get disposed somewhere. So there is much of research funded by Ohio Department of Higher Education. So this is the same agency that, funded our research on microcystins. So on basically investigating, influence of, sludge that would contain, microcystins, how it could be used further. There is also research, that is studying, if water containing microcystins could be used for irrigation. So, look at if microcystin will be found in plants. So, yeah, there's potential environmental risk, to reuse some of those materials that, or apply in agriculture also, some of those materials that we use for water treatment.
Thank you. And then last question might be quick. Why do the harmful algal blooms in Lake Erie start in the western Lake Erie basin?
Yeah, this is another excellent question. So this is the shallowest part of the lake. So I mentioned that, close to Toledo, lake is not very deep as in other parts of Lake Erie. And during summer month, so bacteria to grow, they would generally require, higher temperature. So obviously during summer, here summers are similar as in Serbia, relatively hot. And this water will get warm because lake is shallow, so it's not as deep as Lake Michigan, for example, or eastern Lake Erie.
Yeah.
And obviously we have much of nutrients during that time because rain, rain events are very intense during late spring and during summer. So much of nitrogen and phosphorus would end up in Maumee River and end up in the lake. So those three things are important, sunlight and temperature, nutrients, and obviously lake being shallow. Now, the other part of the lake also has issues, like if you drive 5 hours from Toledo to the east Lake Erie, you reach Buffalo, Buffalo, New York, which has issue with E. coli in Lake Erie. So obviously there are other reasons for that, but just to point out that we all should pay attention to what we use for drinking, you know. So what somebody would say, you know, you don't want to put garbage in what you drink, you know. That thing is a little bit different, but you can imagine, you don't want to contaminate your source of water.
Thank you.
You're welcome.
Maybe I can put some questions.
Yeah.
Thanks,
Okay,
Dragan.
I will.
It was really interesting. I had several subjects during my studies that related to water treatment, but all of this was quite new, and I was firstly surprised if I saw well at the beginning of your presentation that the highest amount of water is consumed for thermoelectric power plants. So, like more than for all the other industry and people consumption. So that was really a bit strange for me. I just how much of that water is evaporated for the turbines and how much is just used for some other stuff. Is it released like liquid water or it just it goes into atmosphere? And is it what's the temperature? Is only the raised temperature problem, or it has some pollutants from the power plant also?
Well, to be honest, I also learned about this by preparing for this presentation. But I can tell you what I read. You know, so this water could become very hot. You know, they were talking about in Fahrenheit, you know, like 540 Fahrenheit, something like that, and in some process even higher. You know. So this reference from U.S. Geological Survey is what I read. You know, about the temperature of water. Now the reason why it's not released, why it should be cooled down, you know, if you would put this into Lake Erie, you know, fish will die, and not just in Lake Erie, like fish won't be happy, you know, won't live in this water, you know, temperature water will change much. So this is why, you know, they have those big towers where they basically spray water to cool it down. And ideally they should, you know, most of that water, you know, will cool down in air and you know, once it gets on the ground, you know, it would have like regular temperature. Now, what has been noticed is that water that is discharged and also proximity of those factories to the lake, you know, increases temperature of water. And this is, you know, sometimes 2 to 3 degrees Celsius, but in some, you know, online website, I saw that it could run up to 10 degrees Celsius more. Now, for overgrowth of microorganisms, this is obviously very important, you know, like during winter, if they have temperature instead of being, I don't know, like 10 degrees Celsius, you know, or less, like 5 degrees Celsius, you know, like instead of that being like, I don't know, 10 or 15 degrees Celsius, well, they will certainly grow more, you know. It's very detrimental for you know, biolife in the lake and rivers too.
I mean, now this is maybe not really smart to ask because they probably meant about that. But if they treat water to use it, and they warm it and cool it a bit, why they just don't recycle use it again? Yeah, and not release it in the lake and take new one and treat it again.
Well, that's a very important thing, you know. To what you notice is kind of reminds me of what I discussed about First Solar. You know, like they should try to improve, you know, production and recycling processes in order to make process more economical. I believe it just more economical to do it from lake, but you know, environmentally, like if they recycle it would be better, you know, instead of withdrawing from lake, you know, recycle, cool it down and use again. But yeah, like that heat transfer will go from the equipment to water, and it is cold, and I guess for them it's easier to spray and then release the steam. But this is a very good suggestion, and I think we have the same issues that with nuclear power plant, you know, like they mentioned like in Monroe, Michigan, they're going to close, you know, this coal-based power plant 2028, but there are, you know, there are other plants on Lake Erie, you know, that can still, you know, use the same process, you know, like we draw water from lake and And
Well,
then
I probably the improvement is quite good because I searched Wikipedia and saw that some old coal power plants use 138 cubic meters of water per megawatt hour, and the new ones around 2. So
Yep.
it's a great improvement, but still it's a huge amount when you compare total water usage for that.
yeah,
I think that Katerina has raised her hand. So
yeah, like thank you, Nicola. I know you have prior experience, so
Hi.
thank you for comments. Hi, Katerina.
Hi, I want to just add something about the water in the power plants. Well, first question was why they don't recycle it. The main problem is that you need extra clear water, demineralized water for power plants and for turbines. So basically, chemical preparation of that water is extremely hard to be recycled. Well, what is then working for the whole system is yes, of course, you use river water or some clear water from a lake, of course. Then you prepare it chemically to be demineralized, and finally, when you use it, you cannot recycle it, but you must clean it and, of course, cold it. The second question is why. First answer is it's very heavy to be recycled, and the second thing is what are they doing for cooling? You have cooling systems, of course, but you have also one good thing with that very hot water or what you are using. What are they doing then? That hot water is used for thermal systems and heating systems for the town and villages nearby the power plant. So you don't just need to cool it down, but you are using that hot water as a secondary resource, secondary sirovina.
Yeah.
So that is the second thing. What are you doing with that water? The main problem is actually turning water from the power plant in the river or the lake, not just because of heat, because heat is easily repaired, but for chemical use. For example, in our water there is also sulfur, a lot of sulfur, and even when you have everything, when you are doing everything right, you're in that moment using some chemicals to clean that water, as are, I don't know, electrolytes or something that you cannot reuse again, and that there is the problem. What do you do with that kind of waste? So basically, water is not the waste that pollute too much. The waste you clean the water is actually waste that pollutes environment.
Yeah, that's
in
great,
the long
Katerina.
run.
I think you mentioned before that you work for one of those thermal power plants, and to be honest, I've never been to a thermal power plant, so I don't know how exactly things work there. I read literature, and this is my first presentation ever, to talk about this. So thanks for this input. I think it's great for this program, to educate all of us, about things that we
Your
know.
presentation was informative for me also, because I never made such a parallel with information, so it was very useful for me.
Great. I see Ivan has a question. Ivan.
Yes, I have one question. I mean, another classical question, but just your opinion in my way of thinking and by looking your presentation. First, I'm quite interested. Are there some older data in the past concerning these bacteria, microcystins? Because you usually, I mean, connected the appearance of these microcystins with rising the temperature and climate change. And for instance, the map you show, basically this bacteria microcystins is appeared everywhere, including and in quite cold sea, you know, and ocean. And also because we are not climate change scientists, just your comments also, is it possible, because I mean, you know that in the past and today there is a large number of the quite respectable scientists in that field that said basically that deny climate change, and they said that the temperature cycles are something quite normal on the planet. And I mean, just connected all of this, is there some connection? Or
yeah, of course, this is another great question. So obviously cyanobacteria are ancient organisms, you know, one of the first, or ancient cells, if you want to call it that way. So one of the first photosynthetic cell on Earth. And you know, the reason why, you know, some scientists support, you know, this, you know, opinion about climate change affecting, you know, appearance of cyanobacteria is, like, one example would be, you know, we have 5 Great Lakes, and one of them is Lake Superior, which is the most north and the coldest water. But cyanobacteria were only recently detected there. Okay, and you know, the rationale is basically that you know, climate change has influenced this, along with, you know, nutrients from, you know, storm events. We also, you know, collaborate with a professor in medical school, you know, who has actually participated in a recent documentary, you know, which was on PBS, public television here. So this is another thing that I can provide to all of you to watch, and hopefully there will be at some point another time for discussion. Basically, so this is a microbiologist from University of Michigan, you know, who is environmental scientist, who also supports, you know, with data, you know, supports some of, you know, this notion that climate change is influencing, you know, more severe effects in terms of harmful algal blooms, as well as, you know, the other weather effects. So it is an ongoing debate, and I acknowledge that, you know, but yeah, there are data that also support, you know, that climate change is responsible for appearance of not only Microcystis aeruginosa, but also some other, you know, toxic cyanobacteria in lakes that had never had them before.
Okay. And for the cold sea and ocean?
For the ocean, they can show up also. Some of them can show up in oceans as well. And you know, like now those would, like nodularia, for example, we produce nodularins, you know, which are common for brackish water. So most of the time, you know, they're found either in you know, fresh water or in brackish water when rivers enter the seas.
Okay. Okay, thank you. It was interesting, you know, to give possibilities and to appear because of also some additional reason, you know, and not just the raising the temperature. So
yeah, like obviously there is ongoing research, and I like this discussion very much.
Yeah. Okay. Thank you.
Stratton, please ask your question.
Yes, I want to ask you, when we have such cases of extreme pollution like the one that you've shown in the lake Vrutsi, close to Užice, pollution that affect obviously water supply in large communities, what can be actually done to fix the problem? To what extent it can be fixed, and what's the time frame in which you can do something meaningful?
Well, this is, you know, like with Lake Erie, you know, Lake Erie hasn't had those algal blooms forever. You know, like there were cases, like, as I remember, you know, from previous presentations from other people, you know, like since 2000 they become more severe, but then there was a period where there were less, you know, there was less extent to it. So I think one important thing is education, and you know, if you tell, you know, farmers, you know, well, this leads to the problem that comes because you put too much fertilizer on the field, both society will benefit to this and farmers, because fertilizers are expensive, you know. So important thing is education. The other important thing is prevention. You know, there are technologies that are used or that are in development, you know, to prevent pollution. So, like, you know, for example, there are agencies, you know, working with, you know, biochar and other type of materials, and also my group partially contributes to that field, you know, like using biochar to remove microcystins and other pollutants. So education, research, and I would say there is big social factor, like in Lake Rutsy, you know, as I read, you know, in this chapter written by Zorica Svirčev from University of Novi Sad and her collaborators in Greece and Serbia and Finland. So the lake was built, Lake Rutsy was built to supply water to city of Užice, but then, you know, people started building houses, you know, and they were runoff going into the lakes, and people started using for fishing and, you know, recreation. And obviously those cyanobacteria, they need nutrients in addition to sunlight. So this led to the pollution. And then they switched the water source. So it would take some time to basically fix those things. And I think those are a few ways to fix it, you know, to avoid, you know, events that lead to contamination. So to decrease nutrients, you know, through either education or some type of prevention program, and to control and monitor, you know, and enforce, you know, certain regulations. But it is a big problem.
Thank you.
Yeah, same in the US, I think, or like here, you know, I think we have many people, you know, that do agriculture, and we know that their lives depend on it, you know, they work on it for life, you know. So it's a situation where, you know, you cannot stop agriculture, but you also need to make those people familiar with the issue.
Thank you.
You're welcome, and thank you for the reference. Any other question?
Maybe just one water treatment
sure.
question, if nobody else. About that, when you said do not drink water advisory. So as I understood, when you have that bacteria, you can do some chlorination, ozonization. But if you have microcystins in the water, is the activated carbon only way of removing them, or there is some other? And how is possible that they cannot be removed, and then that the water is not potable anymore?
Yeah. So basically, removing cells, you know, through coagulation, you know, filtration is possible, you know, and that's the way they do it, you know. The problem came, you know, because cells started lysing, you know, when they were in the lake. So there was overgrowth, you know, cells were dying and lysing. So microcystin as a molecule was already released from the cell. So, you know, once microcystis bacteria open, you know, like toxin becomes extracellular, and then it could pass through the, you know, depending on the level of activated carbon, you know, so activated carbon can remove it, you know, but there is certain capacity. So obviously, I don't know all details what happened in 2014, but you know, there is possibility, you know, that there was not enough activated carbon being used, you know, and there's possibility that some of those molecules that were already released from bacteria, you know, passed into tap water. So the detection technique that they have used is actually ELISA, you know, so it's using a kit, you know, colorimetric kit, you know, so the amount that was found was 2.5 ppb. It was above, you know, do not drink advisory, you know, that at that time was 1 ppb of microcystins in water. So it was for a few days. Some people would argue, you know, that maybe water, you know, should have been allowed for drinking, you know, but obviously because it was very short time, you know, those doses, you know, lethal doses are, you know, if you drink very high concentrations or for very long time, small concentration. But I think it's safer to you know, basically to tell people honestly, you know, like, okay, we detected, you know, don't drink. Yeah.
But that is because they used like standard procedure all the time, and so in some periods that is not enough. But if they just notice on time and modify the procedure, it can be prevented.
That's exactly the case. Now, Toledo has built Toledo water treatment plant, built ozonolysis plant, which now, you know, does much better, you know, fragmentation and this the removal of microsystems. And I'm not sure about their timeline, but yeah, if they use it during summer, you know, they can still potentially keep the same, you know, loading of activated carbon and still remove microsystem more efficiently.
Thanks.
You're welcome. So, Nicola, do you know what the situation with Lake Vrutsi? Because I know you come from that part of Serbia.
As I know, now it's used, people swim in the summer, some fish and that. And as I know, the Sušica spring, I mean, it's strange because Sušica is closer to Zlatibor than to Užice, and there almost never exists river, only after rain. But there is some huge springs underground, which seems to be enough, produce enough water for whole city of Užice. But for me, it's really strange because when I pass there, I never see water anywhere. They just say that it's enough for the city, but it's probably underground. I don't know.
Well, the underground water is a very important component. It was shown very briefly in some of my slides, but yeah, it's important to keep it safe too. Okay, so it's 1:40 p.m. I don't see any more questions.
Yeah, Dragan, I'm wondering if I can just jump in before we finish. I just want to make a note that our next presentation will be December 8th. You can see on the screen here, I'll be talking about photovoltaic system design, and then we do have some things scheduled starting again in January. And in the meantime, I just wanted to say good luck to Serbia in the World Cup. You have a tough first match against Brazil, but hey, it's a good time to start winning. And well, good luck to the United States also.
Thank you. Yeah, same here, Randy. You know, I cheer for Serbia, you know, but if Serbia gets kicked out, you know, cheer for the US.
Yes.
Okay. Well, thank you everyone for your contributions. You know, I'll stop recording and basically we'll post this lecture online on YouTube as well. So Ivana will share that information with you.
Yes, of course.
And we can add your slides to the. We can add your slides to the drive also.
Yeah, and I promise a couple more things that I'll provide for the next time. Yeah.
Okay.
Take care, everyone.
Thank you very much.
Thank you.
Have a good night.
Bye.
Thank you.
Bye.
Bye.